Hi again. So in the last video, we went over the two equations that I derived, and we basically determined that an arithmetic sequence is really just another form of a linear equation. And there are two equations that we've sort of determined. One is the general form, and the other one is for d itself. In other words, we've determined that the common difference is really just the slope of an arithmetic sequence. So let's put this into action. Let's get a couple of examples and see how these two equations come into play. All right. So we're just going to basically do a couple of examples. So let's do the first one. So the first one is, let's say we have a sequence that's like it's not 5, but it starts with 3, 9, 15, and just keeps on going until we get to 1353. So the question is, so for this sequence, how many terms are there in this sequence? So how many terms are there? So like right now we can see there's 1, 2, 3 terms at least, but there's so many unfilled, and so we basically have to find out what term does this last one belong to, like what position does this last one belong to. So let's go over the general equation again. The general equation, I'll use a different color this time. So the general equation is un is equal to u1 plus dn minus 1. So u1 right here is the first term right here. So that's u1 for sure. So we've got that. So let's just write that's equal to 3. D stands for the common difference. So let's look at the common difference over here. Each time we're adding 6, right? We're adding 6 each time. So D in this case is 6. We don't know n because that's what we're trying to find out. N tells us the position number, or how many terms there are. So what we need to do is make sure that we figure out what position number this very last number is. So n stays put, but that's what we're going to try to find out. And obviously un, like we said, it's going to be the nth term, but it can also be the last term. And the last term here is 1353. If we plug in the last term over here, we can find out what position number it belongs to. So all we have to do right now is solve this. So this is going to be 1353. I'm going to subtract 3 from both sides. So it's going to be 6n minus 1. So this is going to be 1350 is equal to 6n minus 1. What you do is divide by 6 on both sides. And if you divide by 6 on both sides, we get 225 is equal to n minus 1. And basically, if I solve this, n equals 225 plus 1, which is equal to 226. In other words, we have 226 terms in this sequence. So if we start from 3 and end at 1353, or 1353, we have a total of 226 terms. And that's it. All right? Let's go over the second example. So the second example that I have is the following. So let's say, for example, you know the second term of a sequence, and that is 4. Okay. Let's say you also know the seventh term of the sequence, and that is 19. So the question is, find the general equation for this arithmetic sequence. Oops. I apologize for the handwriting, but I just want to say that one thing that has to be stated is that you have to know that it's an arithmetic sequence. If you don't know that it's an arithmetic sequence, there's no point basically in doing this, because there are different equations for different types of sequences. So in this case, it's an arithmetic sequence, so now we can use the equations that we have. All right, so if we want to find the general equation, really the general equation is nothing more than un is equal to u1 plus dn minus 1, right? But the problem is we don't know what u1 is. Let me just use a different color. N minus 1. The problem is we don't know what u1 is, because that's the very first term of the sequence. We know the second term, but we don't know the first. And we don't know what the common difference is, right? Un and n, these are variables. These are variables because they change depending on what position you're at and what position you're at. However, the first term and the common difference, those remain constant. So if we can find what these constants are, then we can find what the general equation is. So how do we do that? So let me just write the two terms again. So it's going to be, because it'll be just useful here, so I'll write u2 is equal to 4, and u7 is equal to 19. Okay? So if we recall from the previous video, I had an equation that, to help us find the common difference explicitly. So since we defined it as the slope, it was uj minus uk. And keep in mind that j and k are subscripts. So it's not like u times j and u times k. These are just subscripts over here. Over j minus k. And in this case, these are not subscripts. These are just numbers. So if we use this example over here, you can pick u7 first or u2 first, but I'm just going to pick the higher term first. So in other words, this is u7 minus u2, right, over 7 minus 2. So in this case, what is this equal to? So u7 is 19, so it's going to be 19 minus u2 is 4, so minus 4, all over 7 minus 2, right? And this 7 came from this little subscript over here, and this 2 came from this little subscript over here. So 19 minus 4 is equal to 15. 7 minus 2 is equal to 5, so that's equal to 3. So just right in one shot, we've determined what the common difference is, and remember, keep in mind, the reason why we can use this formula is because the common difference, if an arithmetic sequence is a linear equation, then the common difference is basically the slope. So this pretty much is derived from the slope. All right, so the common difference is 3. Now, how do we find u1, right? So remember, the equation is un is equal to u1 plus dn minus 1, right? So pretty much the same way that when you have a linear equation, if you want to find a constant or something like that, you just plug in a point. That's pretty much what we do over here. So we have, well, let me just write this down. So we have u1 plus, we know our common difference is 3, so we're going to write 3n minus 1, right? So if we want to find what u1 is, let's plug in a point. It doesn't really matter which point you use because they're all part of the same linear equation. But let's say for example, let's use u2 and 4, right? So in other words, this will be u2. So u2 is equal to u1 plus 3n minus 1. But if we're going to use u2, we already know what n is, and we already know what the term for it, u2 is equal to. So instead of u2, I can just say 4 is equal to u1 plus, we know that the n, or the position number, is 2, so we can say 3 times 2 minus 1, and all we have to do is solve for u1. So we could say 4 is equal to u1 plus 2 minus 1 is 1, so that's 3. So therefore u1 is equal to 1, right? Because 1 plus 3 is equal to 4. So if you wanted to write the general equation of this, you can simply say un is equal to 1 plus 3n minus 1. And this is our general equation, okay? So keep in mind, if you're ever just given two terms, and told that it's an arithmetic sequence, you can find the common difference right away using this formula, right? This formula is not going to be in your formula sheet. It's something that I've sort of derived by myself. But anyways, it's uj minus uk over j minus k, and you just plug that in and you can get the common difference. Once you have the common difference, all you have to do is just take one of these points. It doesn't really matter which one. We could have done u7 and we would have gotten the same answer. Plug in one of these points into the general equation. So let's just say we had picked u7. This would have been 19 is equal to u1 plus d. And instead of n, we would replace it with 7 because that's the 7th term. So that would have been 7. And then if you had solved it again, you would have gotten u1 is equal to 1. And finally, this is your equation that we need. All right, so that's basically it for arithmetic sequences. In the next video, we're going to go over arithmetic series and explain what the formulas are and some examples as well.